Hello everyone and welcome. So in this video we are going to see how we can do categorical feature encoding. So we are going to encode our categorical feature in this video in Python. So here I have created a data frame where we have these features, which is ID, quality, product type and available and price. So these are our feature, and here if you see, price is numeric feature and ID is also numeric feature. Apart from this price and ID, quality, product type, available, these variables or these features here are categorical data. So here if you see, this available feature is of binary type. So you have yes and no type of values here, and this product type here, if you see, this is a nominal data, right? So you have name of the product, shirt, shoes, trouser, sunglasses, etc. And here your quality is of ordinal data type because you have some kind of ordering here. So it is good, very good and outstanding, right? So there is some kind of ordering. So let's see how we can encode them. So first of all, we are going to encode this binary data here, which is available feature, and we are going to assign yes as 1 and no as 0. And to do that, I'm going to use map function here. So here all you have to do is data, and in bracket we have this feature which is available dot map, and in parenthesis we give this dictionary. So here it is going to be yes, and yes is going to be mapped with 1, and then no, and no is going to be mapped with 0. Alright, now if you run this, you will have this 1 as yes. So yes has been converted into 1 and no has been encoded as 0. Alright, now let's see how we can encode this quality here. So here this quality is of ordinal data type, right? So we have good, very good, and there is some kind of ordering. So here let's do it using sklearn package. So we are going to do label encoding here. So we will use sklearn package for that. So from sklearn dot preprocessing import label encoder, and here just create a instance of this label encoder. So le equals to label encoder, and now we pass this le dot fit underscore transform, and here you pass your data. So data, our feature which is quality here, and if you run this, let's run this, you have this converted as 0, 1 and 2, and here if you see, you have been assigned 0 for good, and then you have 2, and if you see, 2 is assigned to very good, and here your outstanding is assigned as 1, right? So here if you see, this outstanding is assigned a value 1 which is lower than this 2. Very good, right? So we are not preserving this ordering here, right? So outstanding is having lower value than this very good. Why? Because whenever you use this label encoding, it assigns order or gives number according to this alphabetical order. So here G appears first, right? So it is assigned as 0, then O appears. After G you have O, right? So it is assigned as 1, and V is assigned 3. So always remember that whenever you do label encoding, it assigns this number according to their alphabetical order. All right, now let's move forward and see how we can encode this nominal data, which is here in product type feature. Alright, so to do that, we are going to use sklearn package, and here we are going to use OneHotEncoding. So from sklearn dot preprocessing import OneHotEncoder, and again you have to create a instance here. So OHE equals to OneHotEncoder, and now you have to give this value here. So OHE dot fit underscore transform, and here I can pass this data, and always be aware about this, you have to pass 2D shape here. Alright, so always you have to pass a 2D shape here. That's why we have this 2 brackets. Alright, so here we are going to give product type. I hope we have written the correct spelling, so let's check that. Yeah, it's correct. Now if you run this, let's run this and see what we will get here. So here you have got this result or output which says 6x4 sparse matrix of type class numpy.float64. So here you are not able to see your values, right? Encoded values. And if you want to see this encoded values, you have to write dot to array. And now if you do this, you will be able to see this encoded feature. So here you have 4 new features, as there were 4 unique values in your product type. If you see here, you had this shirt, and then you had shoes, then trouser, then shirt, then trouser, then sunglasses, right? So you have 4 unique values. That's why you have got this 4 new features. And another way to do that is using pd.getDummies. So here all you have to do is you have to write pd.get_dummies, and here you can pass this data. So data, your product type. So let's run this, and here you get this data frame, and you have the feature names as well. So here whenever you have shirt, it will be marked as 1, otherwise it will be marked as 0. So here at index 0 we have shirt, and at index 3 we have shirt, and here this is for shoes. So whenever there is shoes, it will be marked as 1, otherwise it will be marked as 0. And same is for sunglasses and trouser. So one thing I would like to mention here, that here if you have shirt as 1 and shoes as 0 and sunglasses as 0, then automatically by default this means that the trouser is 0 here, right? And the reverse is also true, right? So here if you have this trouser as 0, sunglasses as 0, and this shoes is 1, that means shirt is going to be 0 as well, right? So here what we can do is to not create more features, or to not increase our feature space or dimensions, we can drop this first feature here, or first column for this shirt here. All right, so we are getting the same information. So whenever all of these are zeros, by default this means that it is for 1 for shirt here, right? So what you can do is you can pass this argument here. So drop first equals to true, and if you run this, you don't have any feature for shirt. So here shoes is 0, sunglasses is 0, trouser is 0, This by default means it is 1 for start. So I hope you are clear about this feature encoding techniques in Python and how to perform them. Thank you.